Good afternoon. We're here to talk about OpenTimelineIO. My name is Joshua Miner. I work at Pixar. I'm here with my colleague Stephan Steinbach. We're going to talk for a little bit about our sort of roadmap of the project, and then we have 5 guest presenters to talk about how they're using it. But we wanted to start off with just a quick informal poll. This has helped us in the past to kind of gauge who's using what technologies out there. Raise your hand if you are actively using OTIO in some form. Okay, awesome, excellent. Raise your hand if you were using AAF in some form. Okay, about split, okay. How about EDL? Okay, all right. Final Cut XML, either flavor. Okay, and if you are brand new to OTIO, you don't really know that much about it. Okay. And then are you using OTIO for exchange between one company to another company? Okay, we got one. All right, excellent. Okay, thank you so much. Okay, so we're going to just give kind of an update about the project, where we are with the Academy Software Foundation, and the guest presenters, and we'll leave some time for Q&A at the end. To start with, so OTIO, just to remind you, it's an interchange format for editorial timeline information. It's also an API for working with that data model. And then we include a bunch of adapter plugins for converting to and from other file formats. And we try to emphasize these sort of 3 aspects. They're each independently valuable for different use cases. The data model itself is about tracks and clips and cross dissolves and markers, kind of usual sort of video editing concepts. And importantly, there's media references, so we point out to where media is like external to the OTIO. We don't bundle the pixels or the audio like in the file. So it's very similar to EDL or Final Cut XML in that respect. We also include a sort of debugging kind of diagnostic viewer program. So this is showing you the structure of the timeline, but it's not actually playing back media or anything like that. And you can't edit things in here. It's just kind of seeing like the timing of everything and the track layout. This is our URL. It's all open source. It's all there on GitHub. So feel free to check that out. Internally at Pixar, we've been the past few years sort of rolling that out through our pipeline and kind of replacing a bunch of old legacy stuff there. We've been using it since Coco, and then Incredibles 2, Toy Story 4, and our upcoming film Onward, and all these shows beyond that as well. And we're currently working on integrating it directly into our in-house animation system. And just to kind of highlight that a little bit, the sort of evolution, we started on sort of Incredibles 2 era, exporting EDLs, converting that to OTIO, and running that through our review system and onto our grading system. And this allowed us to improve that pipeline and actually pass cross-dissolve information that previously was not supported in our pipeline, but we could carry that through OTIO. Moving beyond that, on Toy Story 4, we switched to pull AAFs out of the Avid, and that gives us a much richer set of data coming out than the EDLs had. AAF is, we classify it as kind of expensive to work with. It's like complicated. So we right away convert that to OTIO, and then everything downstream uses that OTIO representation to be the sort of very accessible, like easy way to find out what is the cut of the film. In our model, the edit cut is changing dynamically on a day-to-day basis, and so we want the downstream departments to be informed about what's going on with the cut. In our sort of current film pipeline, we can actually round trip this information. So we can have AAFs coming out of the Avid, turned into OTIO, going into our review system, our animation system, all the other sort of downstream departments. But also those departments, importantly, they're often making their own playlists, or they're splicing in their latest renders, those kinds of things. And so we can take those OTIOs and we can turn them back into an AAF and go back into editorial. And this is really, really helpful for that sort of collaboration, that round trip, so that, for example, the layout department can do a couple different, cuts of a sequence, different sort of alternate versions or whatever they need to do, and communicate that back into editorial. So that's kind of how we're using it. You may have noticed that we're part of the Academy Software Foundation track today, and we're excited to announce that we've, just as of last week, actually been accepted into the incubation stage into the Academy Software Foundation. So we're excited about that. It's a cool new community to join. This kind of, we're hoping this kind of aligns with our sort of forward roadmap. There's a couple of things that we want to do that we can't really do just by ourselves as just Pixar. We have a community of contributors already, but we really want to try to make sure that the sort of file format that we're creating is more well specified. So Netflix is helping us with that. We also want to aim for more sort of native vendor integration, and I'll talk about that in a minute. And we also just want to make sure that we're planning the future of the project as a community-based thing rather than like driven by a single studio. It's being successful for us, we like that, but we think that the project will be more healthy if it's more of a community effort. And so, which community? Well, the Academy Software Foundation aligns very much with sort of our identity as an animation studio, and as with Disney as a whole, and reaching beyond that to all the other members of sort of our community. So drilling in for a minute about the vendor integration. So our model right now is you have some third-party applications, and maybe you have your in-house tools, and we're doing a lot of file format conversion to and from whatever sort of native format is used by these applications. So here we can take an AAF, turn it into OTIO, do some manipulations on it, turn it into an RV session file, and show it in review. So that's the model right now. And there's a lot of like hassle or just kind of like messiness around these conversions. And it works in practice. We're able to customize things, and it's kind of okay, but it's not like the ideal situation. What we'd rather have is like native support in a lot of these applications. And we kind of like floated this idea around with a lot of folks. One of the key things there was a lot of these applications didn't want to have a Python interpreter added to their application. So we'll talk about the C++ support in a little bit. But this is kind of where we want to go, and we also feel that by joining the Academy Software Foundation and kind of being more of a community-driven thing, that the third-party vendors will hopefully kind of see this as like alignment, that, okay, if we all sort of want that, like if that makes sense to everybody, then that can be actually like a cost savings across the industry. It can be like facilitating that sort of collaboration. So currently we're still following sort of production-driven priorities, but we do want to kind of shift to more of that community sort of roadmap for the project. We've been accepted into the incubation stage, and part of that is that we actually need to form our technical steering committee and adopt a governance model, and there's some specific sort of procedural steps as well as some technical steps. So actually this week we're reaching out to the other sort of open source projects to find out like, how does your governance work? How are you able to foster a good sort of community involvement? So if you have thoughts on that, if you've seen it done well or badly or whatever, like find us and talk to us. So we'd love to kind of learn from the community that we're trying to join. And with that, I'd like to hand it over to Stephan, who's going to talk about the specifics of what we've been up to on the project.
Hey everyone, so I'm Stephan. I work with Josh on OpenTimelineIO, and I'm going to talk a little bit about what we've been doing since the last time we all met in Vancouver. So the work broadly falls into three categories. There's been, as always, a bunch of work, a lot from the community on the adapters. We've got some new plugin systems that were directly requested by the community, and then finally I'll talk a little bit about the C++ core that we've been working on a lot over the last couple months. So the biggest one for us internally is that we've built out support for writing AAFs as well as reading them. And I need to clarify this a little bit. We're writing composition AAFs, so there's no pixel data in these. It's still just track and information. But for our use case, that's been already super helpful. And I also want to specifically thank the Cargo Cult folks out in New Zealand have supplied a ton of test data, which is really valuable. And I want to put that out there also, that if you're looking for a way to contribute, test data is super helpful, especially with a format as complicated as AAF. But thanks to their contributions, we've gotten a lot more robustness enhancements out of our AAF adapter. And then, of course, as Josh mentioned, that's now been put into pretty heavy production use at Pixar. It's the main interface between our editorial staff and our production departments. Contributed from the community, we've got a Final Cut Pro X XML adapter, and then also a GStreamer plugin that we'll have one of our guest presenters talk about a little bit in a little bit. So I'm going to talk a little bit about some of the new plugins we've introduced. So if you're familiar with the project, you've probably come across this idea of a media linker. Josh alluded to the fact that we don't encode any media. Instead, we have these media references. And the idea is that the media linker is a plugin that you author that has your business logic for your studio that tells OTIO how and where to find the media out on your specific database, disk farm, whatever, however it is that you do it. And the way that we had done that is it runs once per clip. And what we found was that it's specifically meant to replace and edit only that media reference. And while we like the plugin-ness of it, we found that there's actually a lot of other things that we wanted to attach, and we got some requests from the community about this as well. So we introduced the idea of hook scripts. So these plugins are modeled after Git hooks, if you've encountered that. And what they are, it's all Python, and it's basically a Git hook, a hook script is a function that takes a timeline and returns a timeline, and has the opportunity to operate on the entire timeline in one shot. The hooks are defined by the manifest, so maybe it's kind of hard to see here, but on the right, this is what the plugin manifest looks like. So you can point at a particular hook script, it lives in a Python file, and then you can attach that hook to these events that we describe. And you can define your own events that your own plugins can call, but the core API has a hook that runs once after a file gets read, once after the media linker gets run, and then once before the once before the adapter writes it back out to disk. So like one example use case is maybe you have data that you want to inject after you read the file, you do your stuff, and then you strip it back out again before you write it back out because you're going to share it with another studio, or you don't want to archive that data in there, it's transient or something. So that's where plugins like the hook scripts come in. And I know we've gotten feedback from the community that these are starting to make their way out there. So if you're using these things and you do have feedback, please let us know. Also, we've introduced the idea of a schema-def plugin. So the entire schema system inside of OpenTimelineIO, the base class for that is the serializable object, and it provides a whole bunch of different functionality, like versioning the schemas, doing version upgrading, serializing the data, those different pieces. But we pretty quickly hit this idea that actually there are proprietary schemas that we'd like to introduce as well. And that's what the schema-def plugin lets you do. So here's the one from the example. Well, actually, this is just showing the use case of the serializable object is actually how the manifest and plugin system itself is implemented. But the schema-def plugin is defined in Python using the exact same API as the core classes. So if you've looked inside the core, you'll see the serializable field and that it inherits from serializable object, and it uses the type registry. So it's an exact peer of the built-in classes, with the sort of special exception that if you don't have the plugin loaded, OTIO will still round trip the data, but instead of giving you a concrete type in memory, it gives you an unknown schema object. And if you know what you're looking for, you can still access the data dictionary that's on there. It just won't give you a proper type with classes. It doesn't have enough information to do that. But it has the same versioning system available to the core schemas, and you can put additional methods on there as well. So internally, what we've done is we've wrapped up a sort of metadata container for Pixar metadata that includes methods that knows how to look up information in the database or populate various fields based on information that's present. And that automatically serializes and deserializes with the timelines that we encode. And like I mentioned, if the plugin isn't present, you'll get an unknown schema object. So all the data will still round trip correctly. If the hope is that if you had to hand the timeline across to another studio that had a different plugin, they could still give you the thing back and you'd get the original blobs that were in there. But you could also strip them out with a hook function if you wanted to. So obviously the really huge amount of work that we've been, if you're following along, you've noticed it's been a little bit quiet for the last 6 months or so. We've been focused really heavily on this. But the branch has been landed in master, so if you look at the repo today and you install OpenTimelineIO, you are getting the C++ core. That process has been based on a ton of community input. I know we talked to a lot of you last year and over the last couple years actually and gotten a lot of feedback. So just to drill in, we got the message, we built it all on Boost. Nah, it's okay. But the one thing I did want to mention is the other request that did come up was that we use the hourglass pattern. We did not end up doing this. We found that it was going to significantly increase the development time, and the use cases that we encountered, we just didn't need it. So, it's something that can be added in later. We feel like it wasn't necessary here, but please give us feedback if that is already a deal breaker for you. On the flip side, though, it's header-only dependencies. The thing is in a version namespace, and it's been built with thread safety in mind. So hopefully, it's safe to include in your application. The dependencies that we ended up using, so optional light and any are both actually just I forget what the term is, but they're C++ 17 features that aren't present in the VFX platform C++ 14. So those are filling those gaps, and when VFX platform moves ahead, we can strip those out. Rapid JSON is being used for the JSON parsing, which is the same as USD, and then PyBind 11 is what we're using to do the Python binding. So it's been pretty pleasant. That's been a pretty good set of dependencies, and we feel like it should be pretty easy to integrate in your system. And you don't have to build the Python bindings if you don't want to. That's an optional piece. I should say that. So also, the part that we ported was not the Python plugins. We actually left those in Python. From C++, you can read and write the .otio format, and you can still traverse and manipulate all the data. But if you want to use the adapters, you need to you're going to need to do another trick, which I'll talk about in a second. But just to clarify this, one thing we heard from people is that it was important that folks who don't want Python in their, say, nonlinear editing system don't have to actually introduce it as a dependency, that they can just get the core if they want to read and write the format and use the API. But at the same time, we didn't want to throw away all the work that's gone into those plugins and those adapters because it's still super useful and valuable to the project. So what we're sort of proposing is because it's a JSON format, that you can do something in a Python subshell if you need to access those adapters and read the JSON back into your system if you do need to go from another format. But as Josh mentioned, we're hoping that as time goes on, we can get more direct integration with the vendors, and we don't need as many of the adapters to hook up workflows and pipelines for studio work. Pip install and all the ways that you're using OpenTimelineIO should still work. If it doesn't, definitely let us know. That our hope is that the setup.py takes care of everything. And it's out there last week. David Bariff did a ton of the work at Pixar, so we'd like to thank him for contributing the core and the Python bindings. And while he was in there, he also built preliminary Swift bindings, so if you need to run it on iOS or Mac, go ahead and try that out as well. Okay, so we're gonna hand it over to our guest presenters who have some really cool mini talks on how they're using it in their pipelines. And first up, we got Dreamworks. So let's give a hand to Josh and Sean.
Hi, my name is Sean Wallitsch. I am a lead department TD at Dreamworks. I'm working on our new Pipeline X project.
Hey, I'm Josh Burnell. I'm part of the media team. I'm the tech lead, and we are focused on editorial and playback tools. We're going to talk a little bit about how we're using OTIO to run timings through the pipeline. And I guess the disclaimer is none of these images are relevant.
They're just
but
pretty
they're
pictures.
Cool.
All right, so we came into this with a big desire of a pipeline unified timing format. DreamWorks has been making animated movies for a long time. And with that, we had a lot of assumptions about how timing looked in our pipeline. So we usually assume things like 24 frames per second, or a nice single layer timeline, nice simple cross dissolves between our shots. And as our projects got more and more varied, we found more and more projects were breaking those rules and having more requirements on them. So as they broke those rules and had more requirements and started wanting to use different editorial software from our standard editorial software, we kept having to deal with proprietary EDL formats, and every new thing we got required a large amount of ingestion work to make this stuff work. So as it was becoming more varied, as our project load continues to become more varied, so do the demands that we have on our editorial workflows.
He's off microphone and I'm on microphone.
Oh,
Are we
am I
good?
off?
No?
No.
All right. We'll both be on microphone. So anyway, our first idea was to unify on an EDL format that was like standard to one of our third-party editors, which will remain nameless, but we all know what it is. We just weren't able to do that. There wasn't enough color in it. There wasn't enough stuff in it. And so it's similar to what was mentioned before. We had the AAF. So we went over to using the AAF, but then that was just kind of too rich for downstream pipeline tools. So we went to the OTIO format. That provided us a ground truth that we could kind of keep everybody standard on. And then the OTIO format allows us to store our media in non-standard and mixed locations. So using media references, subclasses of media references, and resolvers, we've been able to move our media off disk for some workflows.
Now I'm on microphone as well. So I should mention that our current implementation here refers to one of our pipelines, and Dreamworks is probably not unique in that we have multiple pipelines at our studio at the same time as we migrate from one to another. So where it says current implementation, that's a current implementation that we are talking about right now. Our creative pipeline, across most of our pipeline implementations though, is that it is fueled by the editorial round trip, much like the Pixar presentation we just went over. So editors publish the official timing for a sequence. Artists view that timing. They can make suggestions to change shot lengths, shot order, things like that. They do that with popular third-party and proprietary tools. The editorial then can ingest those changes. They take some, they ignore others, and they publish a new official timing back out into the pipeline.
So yeah, we use OTIO as just the interim with all those tools. So it comes out of editorial, gets translated into OTIO, it gets ingested into the next tool. Using OTIO, that tool makes its own changes and publishes out an OTIO. The nice part is that it allows us to, well, currently we're using those OTIOs to track timing, playback speed, playback order, obviously, and transitions. So we're still pretty basic. But again, we're able to kind of share that media across different type of storage services.
Along the way, we're also storing metadata inside of the OTIOs, so we're keeping pipeline IDs in there. This allows us to keep track of what a shot actually is, no matter how much the clip information itself changes and becomes unrecognizable. But in essence, we're giving everyone in the entire pipeline the ability to contribute to the timing of the sequence, using a variety of editors that we have in it. They can create new versions, they can push it back to editorial, editorial then round trips it, and we track the entire thing.
Yeah, we have a lot of editors, and they want to, at each level of the pipeline, people want to be able to at least suggest timing changes. So last but not least, things that we're working on for the future. We are looking, our next big thing is going to be multi-layer timelines, like the ability to do stacks and things like that live in the timeline. It would allow us to express much richer multiple shot transitions and picture-in-picture. We do a lot of picture-in-picture, and tracking picture-in-picture throughout the timeline in an AAF format is incredibly complicated, and in an EDL format is almost impossible. Complex transitions kind of falls out of that, 3-movie transitions, things like that. It's kind of a stack, it's kind of a picture-in-picture, it's neither of those at the same time, so tracking that is going to be a next big step. Native media generated on the fly when you ingest the OTIO, that's essentially a hook script, which was kind of interesting. So that's one of our next big projects that we're kind of embarking on. And then the ability to track the change of a shot over time, like the hierarchy of that shot or history of that shot. Essentially the ability to know that this was a previs shot and now it's a production shot, and then it might be two shots that became one or one shot that became two. And tracking that through the OTIO timeline as it comes in and out of editorial will be really powerful for our tracking downstream.
So OTIO has made a lot of aspects of our timing pipeline a lot easier, but as Josh spoke to earlier, right now we're still having to do a bunch of the transition layers between our applications, so we're excited if OTIO can get better support in those aspects. But also one thing, being able to rely on a single documented format has been really nice for timing data through the various pipeline, because a lot of applications don't even agree on how to write certain data to certain data formats, or even what a certain data format is and consists of. So we're excited to see what new versions of OTIO bring us as the format and library mature. Thanks.
Hi everyone, I'm Thibault. I work for Igalia. It's an open source consultancy company, mostly specialized in web engines, Chrome and WebKit, Firefox, etc. But we have a multimedia team where we work with GStreamer. So GStreamer is a cross-platform open source multimedia framework. So you can deal with audio and video for anything you want with GStreamer. It basically wraps all the APIs like decoders, encoders, etc. And then you can deal with it with a standardized API on top of all that. It's installed on all Linux distributions by default. And it's used in many industries, such as TVs, set-top boxes, rendering farms, and things like that. On top of that, we have the GStreamer editing services, which is a higher level API to do video editing only, like post-production video editing, where we introduce high-level concepts such as timeline, projects, layers, tracks, etc. So what we thought will be very interesting for us is to integrate GStreamer and OpenTimelineIO. So what we started doing is implementing a XGS adapter inside OpenTimelineIO so that we could convert editorial cuts from any software, any supported format to the GStreamer internal format, XGS, and the other way also, so that we are like compatible with all formats supported by OpenTimelineIO. And on top of that, we wanted to have like native support inside the GStreamer editing services for the OpenTimelineIO format. So we implemented a GS audio formatter, which means that you can load any file supported by audio or an audio file itself inside GStreamer editing services and play back the timeline as with native XGS format. So we have full support of OpenTimelineIO inside the GStreamer editing services, which means that you can just play back. GSLaunch is a very simple command line tool that allows you to, you can describe a timeline with a specific format, or you can load like an external timeline from a file. So here in the first example, we just play a foo.audio, and it just like plays back, doing everything internally, as if it was a XGS file. I mean, yeah, just a description of the timeline we just supported. Then you can render that in the format you want. So here in the second example, we just load the foo.audio file, OTIO, and we render it to a rendered foo.mkv, and we specify the format. Like we say, okay, we want that to be in Matroska with AV1 video codec and Opus as an audio codec. So that just like renders the timelines described by the foo.audio file. And we can also use GSLaunch like a conversion tool. So here we can just like launch foo.xml, which will be in that case like 500 per XML file, and just save it on disk. So it's very similar to the auto converting, but we can just use like GSLaunch because that's a feature that we already had, and it all like natively supported in JS, so we can take advantage of that. I think you missed a slide. The slide was about, we actually went one step down all that, and we implement GS demuxer inside GStreamer, so that inside GStreamer we have like full support of editorial files format, and like if you have a GStreamer-based player, you can just play Final Cut Pro, let's say Final Cut Pro files, and internally you could just like run a GS timeline and play it back as if it was like a native multimedia file. And all that allows us to, in video editing application that use the GStreamer editing services, we can just like load a file that was edited in Final Cut Pro X, for example, and then just load it in PTV, which is the video editing tool that we build on top of the GStreamer editing services. So it's pretty nice. And in the future, we are planning on moving for the GS audio formatter, we would like to use the C++ API. Some bits are missing, as you cannot do the conversion with the adapters with the plain C++ API right now, from what I can see. Something to be done, I guess. And we're actually working on implementing nested timelines in the XJS audio adapter. We added support for nested timelines recently in GS itself, and now we just leverage that in audio. And all that work is all in GStreamer master, so you can just grab it. You have to build master right now, but like in 6 months, it's going to be released, all that, around 6 months. And then we provide binaries for Mac, Windows, Linux, yeah, obviously, and iOS and Android also. Not really interesting in that case, but you could use that there too. Thank you.
Okay, next up we have Unity presenting.
Hello, I'm Mathieu Muller. I'm the technical product manager for film animation at Unity.
And hi, I'm Simon Inwood. I help animation studios use game technology, and we're the tech team behind the integration.
Yeah. So we've been working with Simon's team for the past year to improve the integration of Unity into production pipelines, which are 3 areas: the interop with DCCs, a Python integration into Unity, and our subject, which is OpenTimelineIO, which is based on the Python integration. We also have images which have nothing to do. So integrating editorial into a real-time pipeline, you get the control and organization of your project over sequences through the shots linking to a media or a portion of the media. This media can be a snapshot or a video, like in a classic editorial thing, but what is unique about real-time is like you actually get a live assembly, also control of a live media, which is a live assembly of your lighting, your set dressing, your effects, and so on, and that you can turn on and off. So, yeah, a heavy use of nested timelines this way. Usage, storyboard, you start to taking the storyboard media and editorial, you can import it in Unity Editor as a reference for blocking out, placing cameras, placing actors, maybe do mocap. Or you can some people start directly blocking out in Unity, doing again, placing characters, doing previews, doing layouts, and exporting it as a reference for the animatics, the storyboard, or even the mood board. And also, we see OpenTimelineIO also as a good bridge between production management, asset management, and actually assembling the scenes together, and following the progress of the production. And if you connect the things, the 2 things going in and out, basically you have the editorial, which happens at the place where it makes sense. If it makes sense to change the editorial in Unity because you have control over the media, it's good. If you have somebody who is using a third-party tool, then you can export it because it makes more sense there. Let's see, we actually have a video in an OpenTimelineIO talk to show that in action. I hope it works. Yes. There is no music. I have to sing.
You want to talk about what's happening? Okay, yeah. So we're in Storyboard here. We're in Toon Boom Storyboard Pro, and so we're using their exporting system into EDL. I got to talk really fast. You can drag and drop it inside to Unity. Automatically ascends the timelines. We set up the overlay on the in the viewport. And now we're showing like, okay, well now I have that as a reference, I can start building out, I can start creating assets inside of Unity using their asset modeling tools. None of this is in project management right now. Okay, now, so now I can export it, all those things that were referenced, and they can be uploaded up into Shotgun or whatever your revision tracking tool is. And now we're going to go back again. So we can actually go back again. We can go back into, we can do the conform part back into Storyboard as well. So once you've made some changes there and you need some extra detail added to plates, you can send it back to Storyboard.
So here we recorded the sequence and plus the editorial, and then you can load it automatically in the editing file. Then you change the editing, you export back, and when you open it again in Unity, you have the editorial which has changed. We see popping up, boom, yeah, that's it. So yeah, we've been working on that for the past few months, and it's accessible, it's private alpha, but we want to have as soon as possible it usable by anyone.
Okay, so some of the features, yeah, so we have the timeline integration, so it's integrated, the OTIO comes into and builds a Unity timeline. We use the scripted importer inside of Unity, so it's treated as like a native Unity asset now, and you can render out media clips directly from the timeline using the Unity recorder, and then we're using the adapters, so we're doing the export out and conform back using EDL and XML when we go over to like up to Shotgun or over to Toon Boom or over to Adobe Premiere. And it's fully customizable both in Python and in C#. So the Python from a Unity plugin allows you to go into C# land as well. So you can start writing C# OTIO code. And it's supported on Windows, Linux, CentOS, and Mac. Next slide. And some of the future work. So we're building out a roadmap, and we're really curious to hear from you. So please come and see us. Next, some of the things we're thinking about is multi-takes, the audio edit, so that's why I'm interested in the AAF, going over into Pro Tools, transitions, handling them, at least keeping them and not losing that data, doing the just-in-time linking with the real-time media, so at the moment we expect the scene to be there before we load the OTIO, and then we use the media linker to bind it. We want to do more work on the export or publish, and then back with the conform and repeat, as well as supporting more editorial tools. And inclusion, as Mathieu was saying, it allows us to have editorial wherever it makes sense. It's usually the first in, it is the first in and the last out, that's the saying. Now with OTIO, we think it's awesome because it allows the edit in to actually in the game engine and let the game engine be part of that story. So one of the open questions is about that linking of shots to the real-time media. How does that work, and how does it make sense?
Yeah, we see, for example, maybe USD plus OpenTimelineIO, and then you have full control of the relationships between your shots and your progression. So that would be great. Thank you.
Thank you.
Hi, so my name is Cerundolo. I'm a senior software developer at Marvel Studios. And we started using OpenTimelineIO about 2 years ago when I started at Marvel to start using some self-services for our editorial staff to do turnovers for our DI. Basically, at Marvel, we turn around movies pretty quickly, and also a warning, there are no images in this one because I'm not allowed to show you any. So, all right, so what OTIO provided us was a reliable EDL parsing mechanism. Basically, our method of handing over for DI is using the traditional CMX 3600 EDL as a standard, which is standard. Since it's in Python, it made it easy for us to do a Django development there. It's self-service. Since it's self-service and it's a web, we're using a web integration there. It makes it accurate real-time feedback for editorial staff. And it allows us to share our code easily within our environment, including any changes we make for our custom development. So it's Django, it's Python, easy. What we did in OpenTimelineIO was we extended it a little bit. We needed some extra metadata. So we added, and unfortunately we haven't published this back into OpenTimelineIO, so we should talk about doing that, whether we want to do that or not. But our integration at Marvel has a bit of a custom integration into the CMX 3600 adapter. Basically, that allowed us to do all of our self-services, and that environment works pretty well for us. Oops, and sorry, it's supposed to be animated. That's about it. And it works pretty well, so thank you, OpenTimelineIO.
Hey everyone, my name is Reinecke, and I work at Netflix. We're in the beginning of our adoption of OTIO, but we're already really excited to be contributing and using it in a few places. So today I'm going to talk about two places where we're using it. One use case where I was able to enhance a developer experience, taking advantage of the OTIO tool set, and then another place we were able to create a new trailer conform workflow using OpenTimelineIO. So the first one is this developer experience use case. We have a lot of these sort of 1-minute trailers that are cut in Adobe Premiere by our in-house editing staff. And what they do is they start out with the full set of finished videos from a TV series. And from that, they select about a minute worth of content to generate the trailer. So what's ended up happening is that, oh, you know what? I jumped ahead in my explanation. Actually, what we're going to talk about first in this developer experience is sort of the things that end up falling on editors to do that aren't really part of editorial. Ideally, a film editor is working on selecting bits of material from all these sources, all your dailies, to creatively assemble that into a compelling story. Unfortunately, what ends up happening is on editorial staff, it'll fall to them to do any sort of simple compositing operation, like just quickly cutting together 2 clips or doing a quick overlay. That's not really something an editor wants to do, and it robs time from them making creative decisions. So internally, we've created a service that will helps with being able to do these sort of simple editorial operations. And this is what the request format for it looks like. So if you look at it, you see there's a few tracks in there. Each track is composed of a few clips, and it's overlaying some graphics on some base media. It's pretty simplistic, but actually, if you look at this, there are 2 errors when this timeline renders out. There is a big blank spot in it, and the audio ends too early. So can you see why that's happening from this? Yeah. I'm not super great at converting in and out of 24th, 48,000ths, 24,000 over 1,000 once in my head. So what I did is I went ahead and I built a adapter, which is something that OpenTimelineIO lets you do. So we built this adapter, we submit it to our internal pip registry, and that means that any developer within Netflix can go ahead and pip install this OTIO adapter for this specific service, and that gives them full support for generating, both reading and writing those request JSONs using OpenTimelineIO. And because we're in OpenTimelineIO, that gives us OTIO view now for free. So now that we look at this trailer with this adapter support, we can see why there's that blank spot up here at the top, and you can see why the audio is ending quickly. What this does is this makes it very easy for a service developer, when they run into an issue, to get really good visual feedback to explore their timeline. This is a simple case, but imagine once you get into timelines that are 2 hours long, and they have, I don't know, tens of tracks. So that's been really effective for us. The second is the trailer conform workflow. Now we're back on the right track. We have these 1-minute trailers we generate, and what they do is they start, these editors working in Premiere start with full seasons of a TV series that they're working from, and they cut these things down. Now, we are a cloud native, we have cloud native pipelines in our workflow, so those editors are working on proxy material, and the idea is that once they've arrived at an edited trailer, they'll pull down the ProRes and conform that. Well, there's issues with that. It can be a bit tough to download all that data. So what we've done is sort of a two-pronged approach to adding efficiency to this particular workflow. One, we've created a Premiere Panel plugin that will go and walk through the timeline and analyze what's actually used in the media. And then secondly, we take that and we turn that into a very simplified JSON format, which is a manifest of what frames were actually used in the output trailer. So actually, if you look closely at this, you can notice that we're encoding OpenTimelineIO style rational times, and you'll notice that right there, that's an enormous number. That's a Premiere tick. So if we look at this and we say, okay, this is the full set of episodes, the full length episodes, and you'll notice that little teeny one up there is the intro sequence to this TV show. And we apply that data we had from before. This is done in a Docker container that runs locally on that machine. This is the timeline of what actually got used in that output trailer. So it's just those little slivers all in there are the material that's actually used. So within this Docker container running locally on the editor's machine, we can then build a new timeline wherein we fill in all those blank spaces with just black synthesized frames. And so we now have a timeline where it's all blank space with a locally generated black frame and just the little slivers where they're actually using real content. We can then use MXF wrap, or sorry, we use two pieces of technology. We have something called MESFS that we use internally that allows us to mount the frames that are actually used. And then by linking in those black frames, we can use the MXF wrapper to pull our original IMF frames and cache an IMF to local storage that is only the stuff we need. So we're a data-driven company. Let's talk about the data. Of about 4 hours of source content, we only used about 59 seconds of it in the output trailer. That maps to about 0.4% of the source material, which means we only use 1.3 gigabytes of 388.2 gigabytes worth of frames. So let's turn that into download time. If you're running at a gigabit per second, you go from around 52 minutes to 11 seconds of download time. This is time an editor can then spend plussing out that trailer and building something that's going to connect our members with the content they're going to love. So that's about it. Thank you guys very much.
All right. Thank you to all of our guest presenters. It's really cool to see how this is being used in all kinds of really cool contexts. Just to wrap up, we want to talk about some of our next steps, and then there's a little bit of time for Q&A. Some of the things on our roadmap coming up are we have an addition or a revision to how we actually store time. So we've got a lot of feedback that currently we're storing things as floating point numbers. Occasionally that ends up with some round off errors, and there's some rough edges to that sometimes. So we have a proposal that we haven't posted publicly yet, but we've been sort of working on to move forward on that and do something that we think will work out better. We've also been working on the timing effects and trying to handle like fancier, more complicated ones, and as well as redesign to how we handle like cross dissolves and transitions. So a more like noisy way of looking at that is we can look at this sort of feature matrix. So along one side we have a bunch of features of OTIO, and then across the top we have like all the different file formats, and like so this is representing for each adapter, can we read and or write these different features of things. So they can all handle a single track of clips, but as we go down we've been sort of like building out more and more features. So the ones highlighted in blue are newly added recently. So the AAF support is now both read and write for most of those. There's a couple pieces that need to be filled in there. The GStreamer adapter is new. And then where we're sort of headed next with this is the kind of fancy speed effects here. So we have sort of sporadic support for that in some of the adapters, and we have a conversation going on with Avid about trying to get the nonlinear speed effects information out of Media Composer. And we're trying to kind of thread a line there of not bringing in all the complexity of the superset of how everybody does timing effects, but to have like a nice kind of middle ground that captures the sort of creative intent of that. And with that, I think we were open for Q&A. We have a few minutes. You can ask us or any of the guest presenters for questions.
Sorry, two parts. One, could you go back to the other slide just while we do the Q&A? There's a lot of good information there. Second is, I was wondering if you could get into a little bit more of the vendor partnerships and software vendors specifically who are participating in how OTIO support is going to be integrated into those software packages and used in a variety of ways. Anything that you could share there?
Sure. Yeah, we've had some conversations with Autodesk about some of their products. We haven't gotten into super sort of details with them yet. And then we've had some sort of, Pixar specific conversations with Avid, and then some informal conversations with the Final Cut team. And I think that's kind of part of our hope with sort of representing like a broader community through the Academy Software Foundation, or just through having more involvement for more people, that if we can create like a stronger bond with those third-party applications, that we think that would be great. I mean, seeing what the Unity folks just showed of like, we want that level of support in like all of the applications, right? And so having a company really sort of embrace that and move forward with that, like devote resources to that, like that's kind of like where we want this to go. But I would say it's sort of like early days on some of those relationships. And I totally sympathize. A lot of them are sort of kind of waiting to see, does this have adoption? Is this something they should spend time on? And I think part of what we're trying to show is, yes, this is growing in the industry. People are finding use for it, but there's definitely room to go ahead with that. So if you have specific like third-party applications that you really, really want OTIO support in, like ask them directly, say, hey, Marvel wants this, or whatever your company is, if we really want this, and that can help them to kind of like see the importance of it. Thanks. Yeah.
And this is last question.
So right now, Shotgun said they were working on some OpenTimelineIO based stuff for doing like grease pencil type overlays.
Okay.
I'm curious if you have any plans to either standardize some kind of best practices, or maybe there's another format for that sort of thing. I know you said you're not really focused on recording pixel data, but maybe there's some kind of standard way to do that. Because I can imagine it could be really useful if you're doing interchange on timelines to sort of support those notes hitting a lot of different targets. You can see, the full graphical overlay in time.
Yeah, it's interesting. Our in-house animation system actually has those kinds of overlays. So we were just talking about like, how should we do that? Should we embed that in the file? Should we point to an external file? Those kinds of things. So I think we don't have any concrete plans for that right now, and actually that's the first I've heard of the shotgun feature related to that. But we'd love to sort of engage in that conversation. I think one of the other things that we're kind of hoping happens is that some of those conversations happen a little more kind of face-to-face or via email, and like the more we can draw those to sort of happen on like either our mailing list or the GitHub issues or something, so that we can draw in the voices that are interested in that and can really participate in that, because certainly having that variety of people to work on it, like there's some really, really good ideas that can come from maybe unexpected places or just places that we don't have the context for. So yeah, that'd be great. Oh, the question was about attaching like sketches, like markup overlay things, so like drawings onto the timeline. So, yeah. All right, I think we're out of time. Thank you everybody for coming out, and please feel free to find us afterward.